Exercise 7E, the chain rule, is the first of our, I'll call them overarching rules that we will have to obey no matter whether we're differentiating using this shortcut that we've just learnt, or if we're differentiating a trig function or a log function. In any of those cases, all of those cases, if this situation of a function is occurring, then the chain rule must be observed. Now, just one thing to note, that a way to identify that you have a function of a function is often there is a power involved, or a bracket to a power involved. It's basically what happens is, if I had that y was equal to capital X to the fifth power, we know that to differentiate that, we bring the 5 to the front and we subtract 1 from the 5 as the power. Now, that's fine as long as this x is actually a lowercase x, a variable. The moment that I introduce, for example, if I introduce a bracket into that, y is equal to some bracket to the fifth power, and contained within this bracket is a function in x itself, so it's more complicated than just a simple x, then the rule becomes dy dx is, we must still differentiate as we did there, bring the 5 to the front of this function in x, subtract 1 from the power, so the power becomes 4. Now note that I have not altered the function inside the bracket at all at this stage. However, we still must differentiate that little function in x that sits within the bracket, and we notate that using f-x. So, for example, in 1 above, there is y is equal to 5x plus 1 all to the power 3. To get the derivative, we use the function of function. So we address the overarching function, which is raising this to the third power 3, and we differentiate by bringing the 3 to the front, leave the function exactly as is, subtract 1 from the power. Now, in addition to doing that, so that's like differentiating the first function or the overarching function. Now we've got to differentiate the inside function, and differentiating 5x plus 1 just gives us 5, and so we would simplify that to 15, 5x plus 1 all to the power 2. The situation where you will have to apply the function of function or chain rule is when we have the square root of more than one term, term occurring underneath the square root sign. Now, we know that to differentiate that, to start with, we would need to replace the square root with the bracket, with the power a half. So we would write this now as x cubed plus 4x all in the bracket to a half. And now to differentiate, we bring the half to the front, leave the bracket exactly as it is, subtract 1 from the index, and multiply by the derivative of the inside function, which is 3x squared plus 4. You can only just fit that in there. Of course, a bracket to a power is not the only time that you will need to use the function of a function rule. In example 3, we've got the sign of this bracket. Now, you will learn when we get to the trigonometry chapter, you will learn how to differentiate sine, cos and tan. So the overarching function in this case is sine. That needs to be differentiated. And once we've differentiated, according to the rule for differentiating sine, which we're to learn later, we have to multiply that by the derivative of the little function here in x, which would be, we're going to multiply by 2x minus 1. Another way to look at these is to call the overriding function or the overarching function as, say, u, and we would be differentiating, we replace all of this with u and we differentiate u, and then we go in and differentiate with respect to x. So, in general form, if you've got that y is equal to some function g of another little function, then you to differentiate, you differentiate with respect to the g function, and for you, for now, it will mostly be a bracket to a power. So you'll bring the power of the bracket to the front, subtract 1 from the power. And then inside, and so you can see that we haven't changed f of x yet, not until we multiply by the derivative of the little function inside the brackets. So differentiate the overriding function, don't change the function within, and then multiply by the derivative of the function contained within. You'll see many different ways of notating this rule. So if you've got y equals f of x to n, you'll see the n's brought to the front. F of x is not changing for now. Subtract 1 from the power, multiply by the derivative of the inside function. Now, just be aware that you may not see the rule written in this format in every case. Here, the first function you address is called g, and the inside function is called f. That does not have to be the case. I could have written that as y is equal to the function I choose to call a of m of x. And if that's the case, then dy dx becomes a dash, differentiate whatever a is, m of x, then multiply by m dash of x. So I've just illustrated that here in example 2. So I've just really swapped the names of the f and the g around. So y dash becomes differentiate whatever f is, and don't change the inside function until you are then in a position to multiply by the derivative of the g function. Now, this other format is different again. Here we're writing f of u, where u is a g of x. That seems like an unnecessary complication. Well, it's only done in order to make the original function look a little bit more simple. A function in u. I think I had started at the beginning of this video naming this as a capital X, and then replacing that capital X with a little function. That's all this is really doing. But it's still got the same pattern in that to find the derivative, We differentiate with respect to the f, or we differentiate the f function and multiply by the derivative of the g function. You may see it written as same, and differentiating g with respect, differentiating g is like differentiating u with respect to x. If that's all seeming a bit complicated at the moment, just leave this one. You can leave this format, and I think as we start to do some examples, it'll become more obvious how to apply that. So this is really important. This rule must be obeyed regardless of the functions involved. Recognizing function and function is one of the most important skills you will develop. And to be honest, it's one of the situations most often overlooked by students. You will often not know to apply it if you don't recognize that what you are differentiating actually is the function of a function. So that I would say for you, as you work through this exercise, to really focus on what the original function looks like. Pay particular attention to that, because what it looks like is going to be your only hint in an exam. You won't be instructed to use the function of a function rule. You'll just be expected to recognise by the look of the function then that you need to use the function of a function rule. I'll stop the video there and do the examples. I'll do them with you in class.